Well, welcome, everybody. And I know that we're getting more and more viewers around the world. This is our sixth episode of discussions about coronavirus, plus more, through the McGill Office for Science and Society. And with me today, my colleague Jonathan Jarry, who you've met before, science communicator. And our guest today is Dr. Brian Ward, who's a professor of medicine and microbiology here at McGill, but he's also the chief medical officer for Medicago, which is a company that is on track to produce a vaccine for the coronavirus. So this, of course, is a very hot topic now, and I think we'll get started with that. So, Brian, welcome to the program. And
thanks very much.
I know that your company and your research is all about trying to make a vaccine from plants. Now, this, of course, is a novel idea, I would think, for most of our listeners and viewers. So maybe we can start at the bottom and explain how a plant can be used to produce a vaccine.
Well, so first, thanks very much for inviting me onto the session. I've been interested in what are called nanoparticle vaccines, so little particulate vaccines for a long time, and they can be made in a number of ways. And one of the ways is to put a gene for viral protein, or more than one in some cases, into a plant cell and have that cell produce the viral protein. And if you do it right, the plant cell will actually produce these little tiny structures called virus-like particles that have the viral protein on their surface. And so they are about the same size as viruses. They're about 100 nanometers in size, which is pretty small. Same size as a virus, same shape as a virus. And depending upon the proteins you put on the surface or get the plant to put on the surface, they can actually trick the immune system into thinking that it's seeing a real virus. And it turns out that plants are very good at making these virus-like particle vaccines.
So what plant is actually being used for this?
It's an Australian weed called Nicotiana benthamiana, and it's actually a distant relative of the tobacco plant. And the reason we use it is that, number one, it's a weed. It's incredibly hardy. It grows very quickly, and it has the peculiarity of producing very high levels of protein in the cells of the leaves.
And how is the gene introduced into the plant physically? I mean, somehow it's soaked in a solution, or
it's totally cool. If you think back to your high school biology, the vascular system of all plants, from the biggest trees to the smallest little weeds, connects the leaves to the roots. And it turns out that if you turn the plants upside down into a bath of material that contains a bacterium that normally infects plants, and you've put the gene into that bacterium, the bacterium lives to put its genes into plant cells. And so what we've done is we've defanged that bacterium. It's called agrobacterium. And we've made it non-virulent. It doesn't make the plant sick, but it does very effectively push the gene that you've put into it into every plant cell. So we make a bath of these agrobacteria that have been transformed. In other words, we've added a gene to them that they're ready to insert into the plant cells, turn the plant upside down so its leaves are immersed, and then we apply a vacuum to the roots. And the leaves of the plant, because they're connected to the roots through the vascular system, they collapse like a sponge. And then when you release the vacuum, they re-expand and suck this fluid with the bacteria all through their vascular system, so that every cell in the plant is exposed to this bacterium within seconds. And then the bacteria do what they do naturally. They put the gene into the plant cells. We put the plants back out into the greenhouse, a very carefully controlled greenhouse. They grow for about 7 to 9 days, depending upon the amount of light they get. And then the little virus-like particles are ready to be harvested.
How do you isolate the gene that you then implant into the bacterium?
Oh, so this is pretty standard molecular biology. So you figure out which gene is, or which genes are likely to make the proteins that will provide an immune response that will be protective. In the case of the coronavirus, most people believe that the spike protein, which sticks out off the surface of the cell, the virus particle, that's what the virus uses to attach to the respiratory epithelial cells, the cells that line our breathing tubes. And antibodies directed against that spike protein are able to block the infection of the virus. And so
the original key here was the Chinese researchers who isolated the genes, no?
Absolutely. Yeah. So they released the genetic sequence for this virus, which had a new spike protein compared to the earlier SARS or the MERS viruses. And the next day, we, like a lot of other people around the world, were preparing to make vaccines that targeted that spike protein.
So how far along are you?
Well, we're not as far as we would like to be, but we have produced the candidate vaccine in the plants at fairly high levels. The first animal studies started about 10 days, 2 weeks ago. So we should get our first look at whether the vaccine will drive an immune response sometime in the next 1 to 3 weeks.
There are some, 100, 125 companies around the world chasing the pot of gold at the end of the rainbow. And one question that I think is very important to ask and to get answered is that once someone comes up with a vaccine that they think works, right? How long will it be before we really know that it works in the general population?
Well, so those are really good questions. But let me just step back a little bit, because first of all, you said there's that people are chasing a pot of gold, and that's actually, I think, a little bit misleading. Although if the world needs 7.8 billion doses of vaccine, or twice that if you need 2 doses, then even a vaccine that costs $2 or $3 will make somebody a lot of money. So yes, that's a possibility. However, even the biggest companies in the world, J&J, Sanofi, some of these others, are talking about maybe producing 500 million doses, or J&J is saying 1 billion doses. Well, that's 1 billion doses in a year. And so it's very clear that if we're going to vaccinate the whole world, there are going to have to be multiple vaccines that are used around the world, not just 1 or 2. So we have to hope that many of these vaccines will actually be safe and protective. The first look that you get at protection is if you, for example, vaccinate monkeys and then challenge them. And so the very first challenge studies are actually being reported. One was just reported yesterday in Science. It was reported in preprint about a month ago. But it looks like there's at least one candidate vaccine from China that is able to protect monkeys. We will be doing a primate study, a monkey study, starting at the end of May. And so we will have a much better idea by mid to late June whether our vaccine also has the potential to protect monkeys. And a vaccine that will protect monkeys is actually very likely to protect human beings.
We had Paul Offit as a guest on last week, and one of his concerns was that some companies may be rushing the safety studies. Do you have any such concern?
Absolutely. All vaccines are rushing, and all of the regulators are rushing because they're under enormous pressure from governments and populations that want a vaccine. So everybody is moving at unusual speed. And the animal models for the earlier really serious coronaviruses, like the Middle Eastern Respiratory Syndrome and the first SARS, some of the candidate vaccines that were used in animal models for those diseases showed a clear capacity to cause something called vaccine-enhanced disease, where you get the vaccine, and then if you're exposed to the natural disease, it's actually worse. And clearly, that is not what you want your vaccine to do. I've actually been asked to sit on an international panel that's organized by the Coalition for Emerging Pathogen Innovation, called CEPI, and the Brighton Collaboration, which is an international organization that looks at vaccine adverse events, so bad things that happen with vaccines. And we've been trying to figure out how to advise companies and governments and regulators to follow a licensure path for these vaccines that is least likely to cause vaccine-enhanced disease. But if you think about it, if we need 2 doses in 7.8 billion people, and we need to do that quickly, there are going to be at least 10, 12, 15 vaccines that are used in more than 100 million people. Well, what's the likelihood that all of them are going to work well and safely? We just have no idea. So it's a very big experiment.
Let me put you on the spot here. What is your guess for the first effective vaccine in terms of time frame?
Oh, I think we will have proof of vaccine effectiveness in primates. I think quite a number of the vaccines will show that within the next several months, hopefully including ours. Keep your fingers crossed. I think the proof of efficacy in human beings, we may start to see the early data by the end of 2020. And I think that as soon as we see a vaccine that looks like it provides 50% protection or better, I think you will see emergency use granted by the regulators for first responders, healthcare workers, emergency medical technicians, possibly even school teachers, and obviously nurses and so on.
And chemistry professors.
Well, you'll be on the list somewhere, but not right at the top, I'm afraid, Joe.
Jonathan, I mean, you've been looking into this virus in many aspects. What impresses you, or questions about this particular technology?
Yeah, I did have a question for Brian Ward because we talk a lot about herd immunity, which is not a great phrase. Maybe we should say community immunity. But this idea that, once you reach a certain percentage of the population that are immune to a particular virus, either because they've had the infection and now they've recovered and they have immunity, or because they've been vaccinated, that when you have enough of these people, the virus does not move as much within a population and can help protect people who are immunocompromised or who can be vaccinated. There's been a lot of talk about this for COVID-19, but the percentage of the population that needs to be immune is different from one virus to the next. Can you explain why that is?
Oh, sure. In microbiology and infectious diseases, there's a really important concept called the reproduction rate. And that is, if you take a virus and drop it into a completely susceptible population, how many secondary cases will occur? And so, for example, something like HIV has a reproduction rate that's below 2. It's 1.5 perhaps. So every person with HIV passes it on to 1.5 other people. That's a recipe for a very slow pandemic. Measles, on the other hand, probably has a reproduction rate that's somewhere between 25 and 75. And so if measles comes into, for example, an auditorium with 1,000 people in it, and that one person coughs one time, then everybody in that room is going to be infected who's susceptible. And so the level of community immunity or herd immunity that you need really depends upon what your reproduction rate is. Right now, most of the estimates for the reproduction rate of coronavirus fall between 2.5 and 4 in different communities. So it's transmitted very efficiently, for example, in the long-term care facilities, nursing homes, prisons, cruise ships, and warships, but obviously with less efficiency out in the community. For something like measles, to get community immunity, you probably need about 95% of the population to be immune. And you'll still get 1 or 2 people who will become infected, but you won't get sustained transmission or chains of transmission from one to another to another. Because this new virus, coronavirus, has a reproduction rate that's down in the 2 to 4 range, most people think that if we can get 50 to 60% of the population immune, we will see a dramatic fall off in the spread. And we may be able to protect some of the most vulnerable people in society through that level of community immunity.
If we do achieve herd immunity, is it still possible for an immune person to somehow still transmit the virus?
Well, that's one of the hottest questions right now. Nobody knows. There was so much is being published in preprint form now, where it's not yet peer reviewed, but it's being put out. So a manuscript was just released, I think, day before yesterday, that showed that people who definitely had the infection, if you did PCR tests on them every day, which is a particularly cruel experiment to do, but if you follow them every couple of days with PCR tests, which is the swab test that you put in your nose, most of them had evidence of the viral RNA in their respiratory tissues for 3 weeks or more. Now, they did not publish whether or not those the nucleic acid, the genetic material that was there, meant that there was a live virus there. And so it's possible that those people are shedding viral RNA, the genetic material, but are non-infectious. Lots of people are really interested in that question, though. Do people shed the virus for prolonged periods of time, and are they still infectious? And of course, the corollary to that is, can you be infected a second time? And for the routine human coronaviruses, and there are several, there are at least 4 or 5 that circulate in young kids every winter, you don't have immunity for a very long time after you've been infected by one of those regular human coronaviruses. So we just don't know yet. And that actually is potentially really quite troubling for vaccine development. We may find ourselves in a situation. We don't
know about this virus, but something we do know is that there are a lot of conspiracy theorists out there. And I bring this up because over the last 2 days, I've had literally over 100 emails asking about this video called Plandemic. Clever name, actually, Planned Epidemic, by Judy Mikovits, who at one time was a reputable researcher. Much to my chagrin, her undergrad degree was in chemistry, but then she went on to become a virologist. And she has a history of conspiracy theory. She's an anti-vax person. She thought that she had the key to chronic fatigue with the virus, and she has been totally discredited. And she, of course, now is claiming that there's collusion between Bill Gates, of all people, Big Pharma, and the deep state to launch this virus onto the population so that eventually they'll have the vaccine and make millions of dollars from curing the disease that they created. I mean, this is so absurd that it's, beyond words. And yet this video is scooting around the internet like wildfire. And people are buying into this conspiracy theory. And she worked for Tony Fauci. And now, of course, she's become his enemy. And that he was the one who undermined her and had her arrested, which is total nonsense. She was once arrested for having stolen data on a computer from a lab, not for whistleblowing about the coronavirus. So what do you make of this? I mean, what fuels this kind of nonsense?
Well, I think, sadly, she's not the only person who peddles in conspiracy theories. We just have to look at other people who are suggesting that this virus was intentionally released by a Chinese laboratory. And I think that the most likely reason that she's doing this is that it gives her another 30 seconds of fame. But there are many people who do this kind of thing and don't pay any attention to the consequences of their words or actions. The much more troubling, to me, conspiracy theory is the one that's being propagated by members of the U.S. administration that have the ridiculous story that this is a virus that was released by accident or intentionally from a Chinese lab. It's the sequence of an essentially identical virus was published by a scientist called Dr. Daszak in 1992. And so if somebody was intentionally releasing this virus, they sure took a long time to do it because it was identified in bats in 1992. So all of these conspiracy theories, I think we need to address them, but we shouldn't give them too much oxygen. I think they should be dismissed with good science, and you have to look at the source from which it comes. Well, if Tony Fauci is talking, I listen. If this other person is talking, I don't.
Jonathan has been looking into the 5G business, that the cell towers that have the 5G antennae on there are responsible for destroying our immune system. And I know Jonathan did. How many interviews did you do today on this?
Today, I mean, I could count them, but earlier this week, for the whole week, it's been a lot. Yeah, it's worrisome. I mean, this is unfortunately a trend that started elsewhere. We start to see cell towers being set ablaze in the United Kingdom and Ireland and other countries in Europe as well. I believe New Zealand too. And now we've had 7 of them here in Quebec, some in Laval, some in the Laurentians. And last night there was a young couple that was arrested. And the provincial police have stated that they do believe that they are responsible for all of these fires. And I mean, it's very interesting to see how all of this fits together, because these kinds of theories have been around for a while when it comes to this type of electromagnetic radiation. Telecommunication signals. When 3G was about to be rolled out, we had similar anxieties over that. 4G, same thing. Just Wi-Fi in schools. I mean, there's a whole movement of parents who want Wi-Fi out of schools because they think that those waves are toxic for their children. Even microwave ovens before that, right? There were people freaking out about microwave ovens. And what is important to remind ourselves of is that these waves are non-ionizing. They are very low in energy. In fact, the 5G that is being used by cell phones is 17,000 times less energetic than the least energetic visible light ray, right? So the visible light that we see is on that spectrum, and is a lot more energetic. It's the much more energetic stuff that we need to worry about, things like UV rays, which can cause skin cancer, and X-rays and gamma rays. But, there are groups on the internet, and there are conspiracy theorists making videos online. There are people like David Icke and Alex Jones that are peddling these theories. And the issue here specifically is that when 5G started to be rolled out, we got hit with COVID-19. And some people thought, well, there you go. One this thing that I was worried about happened, and now this big thing, this pandemic is happening. The two must be linked. There's absolutely no scientific connection between COVID-19 and 5G, and yet there are still people who believe that there is.
And unfortunately, there are people who have credentials who push this too. And we do have one at McGill, Paul Heroux, who's a legitimate researcher. He's in, I'm not sure if he's in the medical faculty. I don't know, Brian, do you know if he's in medicine?
I'm not sure if he has an appointment.
Yeah, and I mean, he's all over pushing this idea. And of course, this is very confusing to people because, they hear on the one hand and on the other hand, not realizing that the one hand holds 99% of the scientists and the other hand holds 1%, right? But journalists will write a story and it kind of seems balanced because they've interviewed one person on each side.
Yeah, I was subject to a little bit of that last week when I was asked to give an interview for Radio-Canada, and they asked me to talk about the Medicago plant-based vaccine, but they also asked me to comment on a tiny little company in Trois-Rivières that had $20,000 to make a probiotic that was going to prevent coronavirus infection. And with all due respect to those scientists, they're very good probiotic scientists, but it is wildly implausible that they have the secret recipe for probiotics that's going to prevent coronavirus. And unfortunately, that creates a false equivalency in the eyes of the viewers when you do a 10-minute segment on these two Quebec-based vaccines. And in fact, they gave about 7 of the 10 minutes to the little guy in Trois-Rivières and the probiotics, as opposed to a quite viable, I think, plant-based vaccine.
Sure, because such a seductive idea that you can pop a pill or drink a glass of something.
That's right.
And I mean, this stuff is all over the internet now. Garlic juice and all kinds of stuff. But Emily, is there a question about vaccines that we have there? Yes.
Yeah, this is really one of my concerns. I've spent much of my career doing work in low and middle income countries. Many of my best friends are living in low and middle income countries. Right now, unfortunately, the country in the world that has the highest rate per million population is, in fact, Peru. Peru does not have the resources to deal with this pandemic. Peru also has no capacity to produce vaccines. There is no manufacturing capacity. So who is going to make vaccines for low and middle income countries? We have an unfortunately long history of producing vaccines for us, and eventually we get around to making them available for them, the low and middle income countries. And I think it would be extremely unfortunate if we do that again in the context of a pandemic that is crippling people's economies and killing people in poor countries. And it's not just poor countries. Saudi Arabia has little to no capacity to produce vaccines. Well, they at least have enough money to buy a vaccine. But who's going to supply vaccines for Bolivia or Haiti? Or other countries that have no way to make the vaccines? Are they simply going to wait until everybody else has been vaccinated and then get a few, the leftover doses? Bill and Melinda Gates Foundation are actually doing a great deal of work to try to make sure that this doesn't happen. The WHO as well. But we've recently seen the attempt again, and I'm not necessarily picking on the American administration, but we recently saw an attempt by the American administration to tempt a European company away from Europe in order to produce their vaccine in the United States. It's an unfortunate reality. Borders will close to the movement of vaccines until the populations where those vaccines are being produced have been vaccinated.
Something I've been just looking into in China, which I find, their science just fascinating because they are some aspects on the cutting edge. And some aspects, of course, they're into the traditional Chinese medicine with the cupping and the acupuncture and the herbal remedies and all of that. It's such a fascinating mix. But I was just looking at this paper.
Joe, sorry,
Yeah.
Before you continue that, I'm really hopeful that pangolins prove to be the animal that transmitted this virus from bats to humans, because to me that would be a really lovely payback for the Chinese desire to eat pangolins and to use their scales in Chinese traditional medicine, right? Most of the pangolin species around the world right now are endangered because of the insatiable appetite of the Chinese for their scales for traditional medicines. And it would be, I mean, it's horrible to say it, but it would be a quite lovely irony if in fact that appetite for that particular animal resulted in the launch of this pandemic. It might actually do very good things for the safety of wildlife around the world.
It's not only pangolins. I mean, the Chinese raise bears in captivity for their bile.
Yep.
And I mean, this is just a vile practice because these bears are locked into these cages, sometimes for decades, and they have a catheter inserted into their bile duct to suck out the bile. And then people think that wild bear bile is better than captured bear bile, so there's stress on the wild population. And then, of course, there's the rhinoceros horn story, and tiger eyes, and deer penises. All of this, I mean, yeah, it's terrible. But at the other extreme, they have some very sound science. And I was just looking at what I was mentioning. Researchers who isolated one of the enzymes that is responsible for making the spike protein. And they mapped that enzyme and found that there's a pocket in there which could be blocked by potentially a drug to prevent the formation of the spike protein. And I mean, I just find this, so interesting that they were able to look at the three-dimensional structure and find a pocket into which they could plug a drug, and they've actually synthesized a model compound and showed in vitro studies that this could work. I mean, so at one extreme you have this unbelievable science, and at the other extreme you have the deer penises. It's really something.
Spoken like a true chemist. Say you would be attracted to that as a chemist.
Yes, yeah. I like pockets into which you can plug drugs and then match the exact structure. Because as I always say, everything depends on molecules. If you have a good understanding of molecules, you know how the world works. Something else that we've been seeing a lot of research in is the vitamin D story. And what do you think about that? I mean, the idea that COVID-19 becomes more serious in people who have very low vitamin D levels.
Vitamin D is certainly the vitamin of the last several years. We've gone through a series of periods of excitement for one or another micronutrient. And there are very clear examples of micronutrients that can have very beneficial effects in insufficient quantity, anti-infective effects, or anti-cancer effects in the case of some of the antioxidant micronutrients. One of the best examples actually comes out of China. Again, it's called Keshun disease. There's a region in China where the soil is deficient in selenium. And so everything that grows there, animals, plants, and people, are all deficient in selenium. And it was discovered over a period of about 50 years that deficiency of that specific micronutrient, and only that micronutrient, made people highly susceptible to Coxsackie B virus infections of the heart. And all you had to do was give people selenium supplements, and periodic epidemics that killed hundreds, if not thousands, of people in Khetrun province in China essentially disappeared. And so I'm actually a big believer in this sort of some of the reductionist ideas, which basically means that there is the possibility that a vitamin or a micronutrient can have real impact on our immune system and our ability to respond.
I think that there's pretty strong data. There's a study just came out in Europe where they looked at 20 countries, and they looked at mean blood levels of vitamin D3, and found that where the average blood level was low is where you had the highest incidence of severe COVID-19. So nobody's suggesting that taking vitamin D3 is going to prevent the disease. But what they are implying that the disease, if you get it, is not as severe if you have sufficient vitamin D. So it's interesting, yeah. So what is your guess? What is going to come first, a vaccine or a treatment?
Well, I hope both. I think that there's more of a chance that we will see a treatment that is proved to be effective before we see a vaccine that's proved to be effective, simply because the people who are already sick need to be treated, and you have an answer within a couple of weeks if you have enough people who are infected. With a vaccine and a low attack rate, right? We've got maybe 5 to 6% of the population in most of the world infected with coronavirus now in the first 5 months of the pandemic. If you were to do a vaccine study, you would have to enroll thousands and thousands of individuals in order to find 50, 60 cases over the next 5 months, let's say. On the other hand, for treatments, there's no shortage of people who are being admitted to hospital right now around the world. And so you can actually test novel treatments far faster than you can test novel vaccines.
So Jonathan, I know you've been looking into remdesivir, and the first studies were kind of interesting because it showed basically faster recovery, which is nice, but what we're really after is reduced mortality. Now, I just saw a report today that there actually may be reduced mortality as well as reduced time in hospital. Have you seen that?
I would love to chime in on this, but I haven't had a chance because I've been flooded with interview requests about 5G. So yeah. I have not followed the remdesivir story. It was a little weird last week when I know that the press release has to go out first, but the study was not available at first. We'll see. I don't know. I haven't looked into that.
Brian, what do you think about remdesivir?
Well, I think it falls into the category of it looks like it's better than nothing, but it's not a slam dunk. And it does appear to limit the viral load quite quickly, right? So the what are called virologic outcomes appear to be quite markedly improved. So if you're culturing the virus from the person's respiratory secretions, the amount of virus goes down very quickly with remdesivir. People do appear to have a shortened stay in the hospital, but it's not shortened from 20 days to 2 days.
Yeah.
It's shortened, from maybe 20 days to 15 or 16 days. That's way better than not having a drug that has any impact, but it's not what I would consider to be, the golden bullet yet.
Well, the hydroxychloroquine balloon seems to be deflating very quickly.
Yep.
Not that there was anything really there in the first place, other than the exhortations of someone who should not be exhorting about anything. But I think in some hospitals they're still trying it.
Well, there was some so in all fairness, there were some very good and very smart people who actually thought that it might work. One of the first manuscripts I saw came from Didier Raoult in France, who is a very careful scientist. And reading his manuscript, well, the first clue was that it wasn't published in one of the big splashy journals. It was published in a relatively low impact journal. But, they were good scientists. They were quite cautious, saying, this might have some benefit. We should study it further. The trouble is that a number of people took those kinds of articles and then went big very quickly because everyone was grasping at straws.
But he also has been accused, of jumping the gun.
Sure,
yeah.
But if you read his original article, he wasn't really jumping the gun. He was just suggesting that this had promise. The trouble is, that led to interviews, that led to misquotes. That I don't know him personally, but I know he's a good scientist, and I'm much happier having good scientists speaking than non-scientists speaking.
So what about the current topic right now, the physical distancing and the sort of, quote, getting back to some degree of normalcy? Do you think, especially here in Quebec, with the opening of the schools, is it the right direction?
I'm not going to second guess my colleagues in public health. I think this is a very carefully measured decision that they're taking. It's an approach that was considered by the UK at the level of the country. I think it's relevant that the Swedish government, the public health authorities there, have taken a completely different approach and rolled out very fast testing, contact tracing, but they really didn't shut down their entire economy. I think that if we do it well, and doing it well means that you have rapid diagnostics, contact tracing, and you communicate well, right? This is your guys' jobs. You communicate the message effectively to the people, saying, we're all in this together until there are treatments or vaccines. And, this is not the time to open up the Just for Laughs festival.
The death rate in Sweden, though, is horrendous. Now, do you think it is because it's kind of being telescoped into a short time period?
Yep. Yeah, I do. I'm just right now. I think the Quebec government is they've made a decision, which is not at face value a bad decision, to let the virus perhaps circulate more actively in the youngest, least vulnerable members of the population, to build up some level of herd immunity. I mean, any of us who've had kids know that, and certainly kids in daycare, we know that they are little germ-producing and spreading machines. It seems very likely that there will be quite effective transmission in daycares and elementary schools, and that will benefit the larger population. And as long as we can do that without risking the well-being of those small kids, then that's not necessarily a bad idea. I know they've been taking a lot of heat for their decision, but it is one of the rational approaches to this problem.
Emily.
Okay, now I'm going to try, and I'm going to have to see the audience comments because no one could hear me before. So hopefully they could hear me now. I actually just have a question now based on what Dr. Ward was saying about kindergartens being good breeding grounds and everything for children of infection and virus. Do you think, I'm not sure if you can actually answer this, but what do you think could happen with children in the future? Basically, is this going to be decreasing their immunity going forward? I mean, the whole, sometimes, you let kids, you play in the sandbox, touch dirt, and they're playing with other preschool kids with runny noses because kids need to go to school and parents have to go to work if, they're not really sick. But all of a sudden, anything, my friends aren't letting their children touch anything, whether it's from other people, themselves, the washing hands. There's some like OCD tendencies almost starting. No one can say that, but can know for sure. But I'm very curious what's going to be going forward, and if that will decrease, the children's immunity going forward.
Well, it's a good question. There are clearly some viruses that can damage the immune system. HIV, of course, being one of them. But there are other viruses that are known to cause damage to the immune system, like measles. Right now, we don't have enough information to know if early life exposure to coronavirus will be a long-term benefit or a long-term problem for little kids. Another virus that if you get it very early in life, respiratory syncytial virus, that virtually 100% of kids are infected with early by 2 years of life. If you're really sick with respiratory syncytial virus, you have a really quite substantially increased risk of developing asthma later in your life. We're at such an early stage with this highly pathogenic coronavirus that we just don't know. It's plausible that people who are infected with this virus and end up in the intensive care unit may have damaged lungs, for example, that may cause them to have more limited lung capacity later in life. We'll just have to wait and see and follow these people.
In recent years, there's been a lot of talk about the hygiene hypothesis,
yep.
Right? That kids, because we're being too careful and they're not exposed to the bacteria and the viruses, you have more allergies, etc. Well, now this is exacerbated. Right now, we're so careful they can't even get close to each other. Is this going to have any effect in the future?
It absolutely could. And so, that's on the health side. There's really good evidence. And again, I'll just use the low and middle income country example. Right now, in many countries in the world, the second largest source of foreign capital is money sent home by all of the people who are working in other countries. And because most of those people are working in low-paying jobs, those are disproportionately the people who have lost their jobs. And so there has been a dramatic decline in money flowing from wealthy countries to poor countries. And that money is the most effective form of foreign aid. The families in Mexico or the Philippines or wherever they are, they use that money for healthcare, for education, for food. And all of that has just overnight evaporated. In the 1918-19 influenza epidemic, there are really good studies that look at multi-generational impact on the families that were damaged, for example, by the loss of a parent during that epidemic. And I think we're going to see some of the same with this coronavirus episode, possibly from health, from the hygiene hypothesis, because we're being OCD and protecting our kids from eating dirt, which is probably at some level good for them. But I think there are also economic and psychological damages that may go on for a very long time.
One final question here. There is a scientist, again, seemingly reputable, proper degrees and everything, in the US, who claims that actually shutting everything down and being basically isolated in our homes is bad for the immune system because we're shutting out exposure to everything that is out there. Far-fetched, no?
Yeah, it's pretty far-fetched from the point of view of older individuals, certainly. I think there's a lot of truth in what grandparents say. the sayings that you get sick of hearing them, but one of the old ones is what doesn't kill you makes you stronger. And I think that for a lot of infectious diseases, that probably is true. Not that we should rush out and get our kids infected with everything, but I think it is possible to overprotect them. Right now, we're in a situation where we just don't know enough, or we didn't know enough. But the mortality level in very young kids, the serious infections in very young kids, are very, very low. They're not zero, but they're very, very low. And so that's the decision that the Quebec government has made based on very good public health advice. Quebec has a very, very strong public health infrastructure. Many of these people are my friends and colleagues, and I respect their opinions a great deal. I don't think that the decision they've made to open up the daycares and the elementary schools is necessarily a bad one, but we'll see. If in the next month or two we actually see that this policy backfires and we find ourselves with a big second wave, obviously they'll correct course.
What do you think? When will we see? It's never going to be normal again. We're not going to go back to the world as it was before. But when do you think we'll feel comfortable going to a restaurant, going to a movie?
Well, I feel comfortable going to a drive-in movie tomorrow. I think drive-in movies are going to come back.
They are actually coming back now. There's a new,
sure they are. Yeah, I'm looking forward to popcorn hanging on the side of the door.
With your physical distancing people in your little car. That's it.
That's right.
Yeah.
But I thought that the whole idea of drive-in movies is to not have physical distancing. Right?
Well, you're betraying your age there.
This is 2020 drive-in movies. It's not like it was.
Oh yeah, I have good memories of driving movies, of driving away with the speaker still on the window.
By nature, I'm an optimist, and so I think that we will see things coming back towards normal, with probably several vaccines that will be authorized for use in the first responders and those who are really putting themselves out and at risk. That will result, I think, in a much more rapid evaluation of those vaccines that will allow their much expanded use in the community, probably earlier than the 18-month figure that people have been throwing around. However, once we decide that a vaccine is safe and works reasonably well, we will still have the problem of producing it. And that's why people like Bill Gates are saying things like, the Gates Foundation is ready to spend $1 billion building 7 factories, each of which can produce 1 billion doses of vaccine, knowing full well that only 3 of them are going to work.
One of the most bizarre things is that of all people in the world, Bill Gates is being implicated in these absurd conspiracy theories. I mean, it's unbelievable. Anyway, I think we've learned a lot here today, and it's nice to see that you're somewhat hopeful with the development of the vaccines. And in the meantime, things are looking a little bit better anyway. The weather is getting better. You look out the window, a little bit happier. But the message I get from university still is that it's unlikely that in September we're going to have classes. Looks like we're going to be working on Zoom. So this is not going to be over in the near future.
Well, that is one of our questions, though, and actually by Dr. David Harp, our colleague who is watching. He wants to know about what your thoughts are on about a resurgence in October.
Well, I think we'll get the first clue in the next month or two if a large number of families send their small kids to daycare and to elementary schools, we'll have our first clue. My wife and I have three young adults who are going into two into graduate school and one into engineering, and all of them are looking at unknowns with the start of the school year next year. It is entirely possible that we will see a surge either in the summer. There really is no evidence that this virus has difficulty being transmitted during the summer months, right? A lot of people have, expressed the opinion that maybe it will disappear in the summer. Well, it was spreading actively in the southern hemisphere during the southern hemisphere's summer. So there's nothing magical about the northern hemisphere summer. I think it's entirely possible that as we bring people together in large numbers, whether we do it through the elementary schools and daycares now, or through people doing silly things on beaches or movie theaters or raves, or just the restarting of the school year, each of these sort of mass gathering type phenomenon may result in a resurgence of the virus. It will certainly not be gone by September, October.
No, obviously, with the good weather, people are going to be out walking, biking, whatever. Many of them I see wearing masks even in their cars. Yeah. What do you think? I mean, you're just out walking or biking. What is the chance of being infected?
Oh, I would think very close to zero. For those of us who have worn masks for long periods of time, they are annoying. But I think that there is real value in the message that you send wearing a mask. It's a little bit like the poppy that you wear for Remembrance Day. Seeing people wearing masks, even when they don't need to be, helps to reinforce the message that it's a good thing. I now walk around with a mask in my pocket, and if I'm on my own, I take it off. But if I'm moving among people, even if I'm able to stay 6 feet away from them, I will very often put it on. The exception is walking the dog.
Unless you're a bank teller.
Emily, we can hear you typing.
You probably don't like masks. Okay, Brian, thanks a lot for all of that really neat info. We hope that Medicago does well and that you'll be producing the vaccine and that we'll be able to say you heard it here first.
I hope so too.
Thanks very much, Brian. And thanks, Jonathan. Thanks, Emily. And thanks to all of you who've sent in your questions. And remember that you can keep sending your questions. You can email them to us. And you can check out our website, which is mcgill.ca/OSS. A lot of interesting information there. And we'll see you back here next week. Until then, all the chemistry in your life comes out just right.
Thank you. Bye.
Good night.